very good day to all of you. Assalamualaikum. Today I will present a project entitled as the elimination of a synthesized titanium carbide MXene from alkaline etchant via microwave assisted hydrothermal heating, and my name is Farah Ezzah Binti Ab.Latif, and these are all the list for my research group members. So there will be 5 sections that I will present today, which are introduction, problem statement, objective and scope of study, results and discussion, and the last one is conclusion. So before I explain what is MXene, let me introduce to all of you what is actually 2D material. So as we can see here, pointer. Okay. 2D material is any material that consists of the single layer or many layer of atoms, just like this one. This is the 2D material of graphene. The famous of 2D material is graphene. So since the discovery of graphene, many researchers try to explore more 2D materials. So therefore, we have several types of 2D material here. As we can see here, we have the BP, which is the black phosphorus 2D material, and also another one is TMD, transition metal dichalcogenides, and also here we have the MOF, which is the metal organic framework. So recently on 2011, the researchers found another type of 2D material, which is called as MXene. So since the discovery of MXene, many researchers try to develop and research more and more in terms of synthesis method and in terms of its properties, and also the application of MXene in various fields, and then the application of the composite. So we are wondering here why researchers are so interested in 2D materials. This because of the three unique properties of the 2D materials, which are high surface area, and also the 2D material is easy to assemble building block for nanoscale architecture, and also their excellent structure for the electronic applications. So let us know what is MXene and its precursor. MXene, as I mentioned before, is another 2D material. So this material, MXene, has a general formula which is M, N plus 1, Xn, and Tx. M is any transition metal that we have in the periodic table, and also X is carbon, nitrogen, or both, and also Tx we have here is any surface termination or functional group, which is O for the oxygen, OH hydroxide, fluorine, or maybe chlorine. So N is any numbers, which is 1, 2, until 3. So how we produce the MXene is actually from the 3D material, which is called as MX phase. MX phase having a general formula, which is M, N plus 1, A, X, N. M is transition metal, and A is for any element which is from the group 13 until group 14 in the periodic table, and X here is the carbon, nitrogen, or maybe both, and also from the number 1, 2 until 3. So from this schematic diagram here, we can see that these are for the 3D material, which is called as MX phase. We can see here we have the M, A, and also X. So after we etch or also eliminate the A element from the 3D material here, we will have the 2D material here, which is called as MXene. So this is actually the MXene figure, and also this is the MX phase figure from the 3D material. So we go for the next. So for example, if you can see here, This one is the max phase for the titanium aluminum carbide. So if we remove the Al here, we can produce the Ti3C2Tx, meaning we got the titanium carbide MXene here. So another example is vanadium aluminum carbide max phase. If we remove H or eliminate the Al here, so we can get the vanadium carbide MXene. So these are another various example of the max phase transformation into the MXene. So at the moment, we already know what is actually MXene. So in here, I would like to introduce a little bit about the route and solvent that have been used to synthesize MXene. So from the literature review, there are like 6 categories can be categorized with the respect of the agents and routes applied to synthesis MXene. For example, here for the first example here, most of the researchers using hydrofluoric acid with respect to the conventional heating, hydrothermal heating, tube furnace heating, and also the recently reported method is the microwave assisted hydrothermal heating. So all these methods are using the hydrofluoric acid agent or solvent. So another solvent or agent that have been used to synthesize MXene is alkaline. For example, here natrium hydroxide and also potassium hydroxide. So the method that have been applied to use the to synthesize MXene through this alkaline agent are conventional heating, and also in our project, we are introduced microwave assisted hydrothermal heating using this alkaline agent. So another agent are like phosphoric agent, chlorine agent, and ammonia agent. So the last one, these two methods, they are not using any solvent. They are straightforwardly synthesis MXene from this method. So in our case here, before I explain further, let me explain the term of the delimitation first here. So as I explained before, we have the precursor. So in our example here, the titanium aluminum nitride is the max phase, the 3D. So we need to etch the Al aluminum in order to get the MXene. So in this case, we have the titanium nitride MXene. So this is called as multi-layered MXene. So this is the etching process. After that, when we go for another process, which is sonication process, we have the delaminated of MXene. If you can see here, this is the multi-layered one. So if we delaminate the MXene, we have the single mono-layered MXene. So in our project, the issue we are going to focus here are the elimination of MXene. So the problem that we are going to propose here is to determine the effect of sonication towards the delimitation of MXene. So our solution here to solve the problem is we are going to vary the duration for bath sonication towards the MXene. So when we vary the duration of sonication, we will compare the properties of MXene that we have in terms of XRD and Phi-SEM characterization. So we go to the objective and scope of our study. So as I mentioned before, the main objective in our research is to evaluate the effects of bath sonications towards the delamination of titanium carbide MXene. So on how we are going to evaluate the effect is through the characterization by determining the crystalline phase of MXene through SRD, and another one by determining the surface morphologies of the MXene via V-SEM analysis. So this is the methods in terms on how we are going to synthesis MXene using the microwave. So initially, if we can see here, the max phase as precursor is weighed and gradually added into the sodium hydroxide solution. Then the mixture was bath sonicate for 30 minutes in order to obtain a well homogeneous mixture, and then the mixture then sent for the water bath sonicate for 30 minutes before we are going to put all this mixture into the microwave assisted hydrothermal. So the microwave will be operated for 45 minutes at 180 Celsius. Subsequently, the mixture will then send for the centrifuge and washing cycle for several times until we get the supernatant of pH around 8. And then lastly, the sample we get will be divided into two categories here, which are the sample A and sample B. Sample B will be directly turned into powder using freeze drying process. So sample A we will not undergo for the water bath sonication. Meanwhile, for the sample B, we will send for the water bath sonication under argon condition for 1 hour in order to delimitate the MXene, and then the 1 hour sample of MXene will be freeze dried to turn into the powder form. So this is the result for the SRD. As we can see here, we are going to focus on this area, which is the 9.5 degree. So at this area, there are more highlighting on the elimination of the aluminium. So from the figure B, as the time for the bath sonication increases, we can see that the intensity and the shape of the peak become more sharp. So from this SRD result, it shows that as the time increases, there are more elimination of aluminium, producing a better MXene. So in this case, the 1 hour of MXene is more delimited compared to the 0 hour one. There are three regions of the V-SEM spectra, which are the max phase as precursor, and also the 0 hour MXene, and the last one is 1 hour MXene. We go for the precursor first. Before the etching process, we can see here the max phase, which is the precursor, shows the layered structures. We can see here. So after the etching process, without any bath sonication, which is called a 0 hour MXene, we can see that the material is partially etched, and the ridges here is white and also shown with the rough surfaces. So in comparison, on the other hand, we can see from the 1 hour MXene here, we get more apparent of ridges, and the size of the ridges is narrow and sharp, indicating that more aluminium is etched from the precursor. So as a conclusion from our result, we can see that the SRD result shows that 1 hour of MXene have higher removal of aluminium compared to the 0 hour MXene. And then for the V-SEM results, we can see that 1 hour MXene also shows more apparent and rigid narrow MXene compared to the 0-hour one. Thus, our significance project in this work enrich the prospect to tune the properties of MXene. So this is the list for the reference. So that's all from me. Thank you.